Hello everyone, and welcome to another Leetcode video. Today we're looking at the problem, find the minimum time to reach last room 2. So this is very similar to the first version of this question. If you have not watched my first video on this, I definitely recommend you watch that first, because that kind of is the basis for this version. They're basically the same, besides one small change. So we're going to be given a dungeon with n by m rooms arranged as a grid. We have a 2D array, move time of the same size, where the value in each cell represents the minimum time in seconds where we can start moving to that room. And we're going to start at room 0, 0 and try to get to the room at the bottom right of the grid. The difference between this and the first version is that we actually have to alternate the amount of time it takes to move to rooms. So the first time we move, it's going to take 1 second, but then the second time will take 2 seconds. And we'll basically go back and forth between 1 and 2 for each of these adjacent moves. So we want to return the minimum time it takes to get to the bottom right of the cell. So we'll look at this example, which is the same example that we looked at part 1, but in this case our output is 7 instead of 6. And that's because similarly we're going to start at 0, and we have to wait until time 4 before we can start moving to another cell. So we move from 0, 0 to 1, 0 in 1 second. But then from 1, 0 to go to 1, 1, we have to actually take 2 seconds to do this. And that's because, as it said in the question, we have to alternate the amount of time that it takes. So the first time we move, it will take 1 second. The second time will take 2. The third time will take 1. Fourth will take 2, and so on and so forth. So we're going to solve this in a very similar way to the original. We're just going to add one extra variable to keep track of. So in our original question, we had this heap that we used to process our Dijkstra's algorithm, but we only had 3 arguments in each element in the heap. So originally we kept track of the time, which is the current time that we're on, our current row, and our current column. Where for this version, we're also going to keep track of the current move that we're on. This is just going to be an integer, and we're going to use this to be able to tell if we need to take 1 second to move or 2 seconds to move. So the way this will work is we'll keep track of, again, our distances, and we'll say we're going to pop this off, and we'll say at 0, 0, we saw that it takes 0 seconds to get there. Then what we're going to do is we're going to look at all of our neighbors. So we can go to 4, say that it'll take time 5 because it takes us 1 second to move there. We'll go to 1, 0, and we'll record move 1. We'll also have here 5, where we're going to have our row be 0, our column be 1, and our move be 1. So now what we do at this point is say we can pop this off of our heap and process its neighbors. First we would say we can go to position 1, 0 in a time of 5, but then when we process the neighbors, what we'll see is that since our move is 1, when we actually move from this position to this position, we have to consider a different value for our seconds. So what we're actually going to do is say, well, I'm at time 5. I see that this value is less than the minimum, right? So I'm at 5. I'm able to move here. In the previous version of the question, it took 1 second. But now what we have to do is check this move value. And if this is odd, we know it's going to take 2 seconds. And if it's even, it will take 1 second. So in this case, we're at time 5. We just need to move 1 cell. But because this is odd, we know we have to actually add 2 to this value rather than 1. So to get to here, we have to do our 5 plus 2, which gives us our answer of 7. So really what we're going to do is basically the same as part 1, but we're going to keep track of this move variable as well. And every time we make a move, we're just going to increment it and just do this logic every time we make a move to adjacent cells. The time complexity here is exactly the same as in part 1. The only difference is we're just keeping track of this move variable, which doesn't really affect anything. Let's hop over to the code and see exactly how this works. So the code starts off basically the same as part 1. The only difference is that in our heap, we're going to have one extra variable here, and this is the current move that we're on. So similarly, we're going to pop the top off of our heap. If we've already recorded a distance to get to this position, we're just going to continue past because we don't want to do it again. We already know that whatever we've recorded is going to be the lowest. Then this is an optimization to avoid time limit exceeded for this version of the question. Our constraints are a bit higher, so we're doing a special check here to see that if we're actually at the end of the grid, we'll just return and not wait for everything in the heap to process. Because it's very possible that we could get to the end, we could record a time to get there, but there's still a lot of other edges in the heap that we have to process and try out. So we're kind of prematurely stop if we ever get to the end because we know that's the shortest time, and we're just going to end at that point. We're just going to record whatever time we're at in our distances because we know that it is the shortest one. And then what we're going to do is just go through all of our neighbors and check if they're in bounds. Here's where we actually calculate our new time. So our default time to move is going to be 1, but if the move we're on is odd, we're just going to add 1 to that to account for that extra second that we have to take. So then what we do is we say, if whatever time we're at is more than the minimum required to move to that cell, we're just going to add to our new time whatever our time to move is. Otherwise, our new time is whatever time we have to wait. So say that is 4, then it'll be that 4 seconds plus our time to move, which will be either 1 or 2. Then what we'll do is we're going to push all of that back onto our heap. But notice that we're going to take whatever our move variable is and increment it by 1 so we can keep track of the current move that we're on. Then the same thing at the end, we're just going to take our distances and return the value that it takes to get to that bottom right cell. So let's submit this and make sure that it works. And it does work. So hopefully that was helpful and made sense. If you liked the video, please like and subscribe, and thank you for watching.